All right, let's continue this fifth grade journal. Let me share my screen and let's go. There we go. Right here. All right, we did this first page. We talked about it. Remember, pause and watch whatever you need to, whenever you need to. Let's go to this. Let's start. 49.357. 49. This is showing you where everything is. The 4 is in the tens place, or 40. The 9's in the ones place, or a 9. Decimal. 3 tenths. 3 tenths. 3 over 10. I'm showing you both ways. It's like dimes. It's where the dimes would go if it was money. Always pretend it's money. 5 is in the hundredths place. So notice it's in the hundredths place right there. So 5 is in the hundredths place. So 5 out of 100. See right there? I'm moving this cursor around. Like pennies. 7's in the thousandths place. 7 in the thousandths. So 7's in the thousandths place because it's right there. Like pieces of a penny. Smaller as you go to the right. If you rounded it to the nearest tenth, it'd be 49.40. There's examples of rounding later, but as written, it's 49 and 357 thousandths. You write it the way you say it. 49 357 thousandths, so 357 over 1,000. Now, how did I get rounded to the nearest tenth? Well, tenths is here, so my rounding rule is 5 or more out of one next door, but first circle the one you're looking for. So circle the tenths, underline the 5 and 7. Then you destroy these because they're underlined, but before you do it, is there a 5 or more next to the 3? Yes, so add a 1. So it becomes 49.4. You can add a 0 to the end if you want. That's how you do it. Just a quick example. Here's more of how you write them. 2 and 348 thousandths. Look, 2 and 348 over 1,000. 2 and 5, that's hundredths, so 2 and 5 over 100. 2 and 5 tenths, 2 and 5 tenths. Remember, these are not the same thing. I see a huge mistake every year. Students come in thinking, remember, pretend it's money. This is like $2.05. This is not $2.05 here. That's $2.50. Remember, that's the dimes place. It's the tenths. Don't be confused. Pretending it's money is the easiest way to solve these things, I guarantee. Look right here. 3 tenths. Here it is with bars. 3 tenths. Pretend these long sticks are dimes out of $1. 3 tenths, decimal 3, decimal 30. You say it differently, but they mean the same thing. 3 tenths is equivalent. Remember, equivalent, equal, equivalent. Think about that word. They're equivalent. They're the same. The decimal 30, same thing. 65, these little ones are like pennies. There's 65 shaded in, so it's 65 hundredths, or 65 out of 100. That's how many are shaded. They could trick you on a test and say not shaded, you know. Pretend they are money. That is so important. Parents, if you see this too, remember, emphasize that. Pretend it's money. I've found year after year of doing this, that if they pretend it's money, it's easy to solve. Here's showing you that between every whole number, a 2 and a 3, these are whole numbers, are decimals. This is not a complete picture. It's just some of the main ones. 2.1, pretend it's money, like $2, 2.00, $2.10, $2.20, 30 cents, 40 cents, 50 cents. That would be in the middle, right? So wouldn't that be 2.5? Because decimals and fractions or division are the same thing. So 2.50, 2.5, all means the same thing. $2.60, 70 cents, 80 cents. Well, that's 2 3/4 because 3/4 is decimal 75 cents. $2.90. If you could really add it all between there, you'd have $2.91, 92 cents, 93 cents, 94 cents, 95, all the way to $2.99 would be right up to the 3. This is just one example. You got it. Like I said earlier, memorize your multiplication, memorize your fractions, what the decimals are. There's a page for that later. Comparison symbols, you got to know them. So, greater than, the wide side toward the bigger number. It eats the big one, as some people say, but that's not always, you don't necessarily want to say it that way, but I'm saying whatever works, works. Is 6 greater than 5? Well, look, of course it's bigger. The bigger side toward the bigger number. It points to the small number. See how it points at it? It's like pointing at it, like that, like that. Look at it. It's pointing at the small one. It's being mean. Don't point. 4 plus 4 is what? Well, wouldn't you add those together? 8 is less than 5 plus 5, because isn't that going to be a 10? This is less than. Equal is equal. It's called equivalent. Means balance on both sides. A lot of people don't understand that. It means balancing. Right here. When I was a math specialist, this was a problem a lot of kids missed. They would say 5 plus 3 equals blank plus 2. You know what they'd put there? What would you put there? Pause the video. Did you put an 8? You would be wrong. Remember, they don't understand what equals means. It means balance. It means to be the same on both sides. If you put an 8 there, that would make that a 10, wouldn't it? Because 8 plus 2 is 10. Shouldn't it be something that makes it equal an 8? Couldn't you put a 6 there? Wouldn't 6 plus 2 be 8, and that's an 8? That's why it's a 6, because balance. Is decimal 5 greater than decimal 43? Pretend it's money. Remember, that is not 5 cents. That is what? 50 cents. So 50 cents is greater than decimal 43 cents. I'm pretending it's money. Now, right here, this is less than, greater than, equal to. 5 plus 2 is 7, so 7 is greater than 6. Decimal 7 is less than decimal 64? Is it? Is that true? Think of decimals as money. Decimal 7 is not 7 cents, it's 70 cents. So 70 cents is less than 64 cents? Is it? No. This should actually be greater on this side. I'm trying to trick you to see if you're paying attention. Now, $49.35. I'm pretending it's 49 and 35 hundredths, but here's a decimal. 3 is the tenths place, 5 is a hundredth, smaller as you go to the right. Decimal 65 is 65 over 100. Decimal 6 is 6 tenths. There you go. Now, I want you to do this right here. Put them in order from greatest to least. Before we do that, I want to pop this up here again. If this was money, this would be like $2.34 plus a little more. The thousandths is like pieces of a penny. So you would hide it with your finger. I'd put my hand up over the 8. You see my hand? I'd put it on top of the 8, cover it up, and then it's 34 cents plus a little more. That's how I figure them out. That helps me solve problems like this right here. Put it in order from greatest to least. Decimal 5, I would add a 0 whenever it's like that because it's 50 cents. That's 9 cents. That's $2. That's not 2 cents. If it was, remember, if you don't see a decimal, it's always behind it right there. That's $2. 2.00. What is that? Okay, that is not $3. It's not 3 cents. It's 30 cents, and that's $1.50. So if I want it from greatest to least, the biggest one would be $2. Then it's $1.50, 50 cents, 30 cents, 9 cents. Now, when you rewrite them, you can drop the stuff you added afterwards and make that just the 2 again, but that's how you tell. If it was least to greatest, you would just opposite, right? Here's how you round. I said it earlier, but here we go. Rounding 5 or more, add a 1 next door, but first circle the one you're looking for. Underline everything to the right of the circle, and it gets destroyed. It's really an adding problem. Let's look at some and see. Round. Estimate. Oh yeah, you got to know that rounding, estimating, approximately, close to are words they use to mean rounding. Approximately, close to, about. Decimal 35 is, by the way, if that was money, that would not be 35 cents. You would be tricked. That is 3 cents plus a little more. So if you rounded it though, it would be for about 4 cents. Because remember, if I want to round, it depends on what I ask you though. If I say round to the nearest hundredth, you would circle the 3, underline the 5, you add a 1 to it because it's 5 or more, so it's 4, get rid of the 5, and it's 4 cents. Look over here is a better example, you can really see it. 54,784 round to the nearest thousand. So circle what you're looking for, underline the rest. This all gets destroyed, but before it all becomes zeros, think it's on a hot plate, everything's melting, like butter. Melting. It's destroyed. But there's a 7, so you add a 1, so it's an adding problem. See right here, I'm showing it. You got right here, zeros, but add a 1 to the 4, make it a 5, so it's 55,000. 5 or more at a 1 next door. Round, 5 or more at a 1 next door. About, estimate, approximately. 137 to the nearest 10? Well, 1's 10, circle the 3, underline the 7, but add a 1, 140. Rounding is pretty easy if you pay attention. Now, the next topic is this, and I'm going to go ahead and do this page. So I can knock out another page, and then I'll stop the video and go to the next section. This is TEK 3A through 3G. You have to know this is times, plus, minus, divide. These are the 4 operations. The answer to a times problem is product. To an add is sum. To a minus is difference. To a division is called the quotient. Now, you got to know how to estimate, adding, subtracting, multiplying, and dividing, the 4 operations. You got to know how to multiply a 3-digit times a 2. Here's an example. Quotients, 4-digit dividend by a 2-digit divisor, like that picture, 2,876 divided by 87. Multiplication of decimals with products to the hundredths, using objects and pictures and area models. Solve for products of decimals to the hundredths. including situations involving money, strategies based upon place value understandings, properties of operations in relationship to multiplication of whole numbers, like 23.7 times 5. You got to know how to move a decimal over. Quotients of decimals to the hundredths, like 2,876 divided by 8.7. 4-digit dividends and 2-digit whole number divisors using objects and pictorial models, including area models, blah, blah, blah. Solve for quotients of decimals to the hundredths, up to 4-digit dividends and 2-digit whole number divisors using strategies and algorithms. Oh my gosh. Including the standard algorithm. 2,876 divided by 8.7. Now, know your multiplication tables. I'm going to shrink this down. Memorize them. I kid you not. This is the most useful thing you can do, is memorizing these. I'll stop on this page. We'll do the next one later. Right here. 6 times 0 is 0. But I would all the way up to the 9s is the most important, honestly, to be honest. These other ones are good to know, like the 10, 11, and 12s, but up to the 9s will help you with division. So focus especially on this area here. These are the hardest, I think. But the 12s aren't as important as knowing up to the 9s. Honestly, that you'll find that to be true. Knowing them is good, but not as important as those. And I would draw this out, draw this picture here, pause the video, and do this. Fill this in. You know how to do this, don't you? 1 times 1 is 1. 2 times 2 is 4. Or if you want to go straight down, 1 times 1 is 1. 2 times 1 is 2. 3 times 3 is 3. If you filled it out this way, 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. If you did it right here, 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, would go right there. 6 times 6 is 36. It would go right there. 10 times 10 is 100. You could do it right there. Just like 10 times 9 is 90. It would go right there. 6 times 8 would be 48 right there. I'm just showing you how to use it. So I'll pause the video, write these out, learn them. I kid you not. You'll be so thankful, and you'll be ahead of everyone else. Most kids don't come up knowing their multiplications like they should. That's just a fact. I've seen it for so many times. You don't have to be one of those. Learn them now. It's not your fault if it wasn't taught to you. I admit that. But it is your fault if you don't learn them now as far as trying. Not saying you're going to be as quick as another person, but who cares? I was not the fastest in my class, but I beat most of the people because I took my time and I paid attention. That's the key. Don't be the first. Don't be in a race to be the first one done, to be the first one wrong. The end of this video, I think. Boom.